Okay, so now we're looking at number 10. Given the information below, find the exact values for the addition formula of sine, the cosine formula with some, the addition formula with that, sorry, and the quadrant that the alpha plus beta is in. So typically in this scenario, they tell us a little bit about each angle, and we're supposed to find all of the ratios that we need, and then figure out what the sine of the addition would be, the cosine of the addition, and then what quadrant does that actually mean that addition angle would lie in. So if we draw a picture for alpha, this is going to be my alpha picture, they told us that it's in quad 2, so that's good information. So this is alpha. And they told us the tangent of it is -4/5. So remember, tangent is opposite over adjacent, so it's 4/5, and the negative has to be on the x in this quadrant. We would then use Pythagorean Theorem to find the other side of the triangle. So that would be 16 plus 25 equals c squared. So that's going to be 41. So square root of 41. And then we would need to find out some stuff about beta. Well, before we do that, let's go ahead and write what these ratios are. So sine of theta we know is opposite over hype. So that'd be 4 over square root of 41. We would not leave it like that. We would put it as 4 square root of 41 over 41. Cosine of theta would be -5 over square root of 41, or -5 square root of 41 over 41. And then tangent we know is -4/5. Okay, so then we're going to move on to beta. So beta is in quad 3. And they told us the cotangent was 6/5, so that's going to be 5/6 for tangent. I don't know why I was calling all of these theta over here. This is alpha. Probably tired. Alpha, alpha, alpha. Okay, so we already know the tangent of beta is 5/6, so opposite over adjacent. And we're in quad 3, so they have to both be negative, which is why it comes out positive. So this would be 36 plus 25 equals c squared. So that's going to be 61. So square root of 61 for my hypotenuse. And then, so that means that sine of beta is going to be -5 over square root of 61, or -5 square root of 61 over 61. Cosine of beta is going to be -6 square root of 61 over 61. Okay, so we have all of that information. Now we're going to use the formulas. So remember, sine of alpha plus beta is social, so sine of alpha with cosine of beta, and agreeable, so plus cosine alpha sine of beta. And we're going to go ahead and plug this in. So sine of alpha was 4 square root of 41 over 41. Cosine of beta would be -6 square root of 41 over 41. Or 61, sorry, not 41. Let me erase that. Plus cosine of alpha is -5 square root of 41 over 41, and this bottom down here is also 61. And then sine of beta, which is right here, is -5 square root of 61 over 61. I'm running out of space. So this would be -24. I have no idea what 41 times 61 is, but we're going to find out. This is why this is in the calculator portion. That's square root of 2051, or 2501. And then we need, that's going to be our denominator as well, since it's still multiplying the same two things. This is -5 times -5, so that's going to be +25, same square root, over 2501. So if we add those together, that's just a square root of 2501 over 2501. So that's the sine of alpha plus beta. Okay, and then when we look at the cosine formula, which I didn't give myself a lot of room for. Cosine of alpha plus beta is cosine alpha, cosine beta. They're disagreeable, so minus sine alpha, sine beta. So cosine alpha is negative 5 square root of 41 over 41. Cosine of beta is negative 6 square root of 61 over 61. Minus sine of alpha is 4 square root of 41 over 41. And sine of beta is negative 5 square root of 61 over 61. Okay, if we work that out, that's going to be a 30 square root of 2,501 over 2,501. Negative times negative is positive, so plus 20 square root of 2,501 over 2,501. So cosine of alpha plus beta is 30 plus 20, that's 50 square root of 2,501 over 2,501. Now those are really big, nasty numbers, but they're both positive. The only time sine and cosine can both be positive is if you're in quad 1. All right, so that's that one. All right, for 11, we're doing something similar, but we're using the subtraction formula. So sine of alpha minus beta, cosine of alpha minus beta, and then the quadrant that would end up being in. So let's again draw what we know about alpha and beta and label all things about the triangle that we'll need. And then we'll figure out our formulas from there. So cosecant is negative 7 over 6. I'm going to go ahead and change that to sine of alpha equals negative 6 over 7. And we're in quad 3. So negative 6 over 7 is the opposite over the hypotenuse for sine. So then this would be 49 minus 36, since we're doing hypotenuse minus the leg squared. So that's going to be 13. So this is square root of 13, but it is also negative. So that means that sine of alpha, we already know, is negative 6 over 7. Cosine of alpha is negative square root of 13 over 7. And tangent of alpha is opposite over adjacent, which is 6 over square root of 13, because they're both negative, so it's going to turn into a positive. But that is 6 square root of 13 over 13. And then we want to do beta. So what they told us about beta is that it is in quad 4. And its cosine is 7 over 8, so adjacent over hypotenuse. That's going to be 64 minus 49. So that's 15. So that's square root of 15. And in this quadrant, the y's are negative. So I already know cosine is 7 over 8. Sine of beta would be negative square root of 15 over 8. And tangent of beta, which we don't actually need for this problem, is negative square root of 15 over 7. Okay, so we're supposed to do sine of alpha minus beta and cosine of alpha minus beta. So let's do sine first. So sine of alpha minus beta would be social and agreeable. So sine of alpha paired with cosine of beta minus cosine of alpha with sine of beta. So that's going to be sine of alpha is negative 6 over 7. Cosine of beta is 7/8. And minus cosine of alpha is negative square root of 13 over 7. And sine of beta is negative square root of 15 over 8. So that's going to be a negative 42 over 56. Minus times minus times minus is actually going to be minus. And 13 times 15 is under the square root. That's 195 over 56. So notice these both are negatives. They pulled the negative out so you could see that the fraction is an overall negative on the answer key. That's going to help us with our sign quadrant thing in a minute. And I did do this one correctly in class. I don't know why my brain was telling me that I had the formula backwards, but cosine of alpha minus beta is, remember, antisocial and disagreeable, so it's actually going to be cosine alpha cosine beta plus sine alpha sine beta. So then cosine of alpha is negative square root of 13 over 7. Cosine of beta is 7/8. Plus sine of alpha is negative 6 over 7 times sine of beta is negative square root of 15 over 8. This is negative 7 square root of 13 over 56 plus, because that's negative times negative, 6 square root of 15 over 56. And to know whether or not this is a positive or negative, you actually would probably need to compute whether or not that top is actually positive or negative. You can't just assume that because the first sign is negative that the whole fraction is negative. So square root of 13 times 7, and it's going to be negative, is a negative 25.24. 15 square root times 6 is a 23.23 or 24. So this is actually bigger than this. So this overall sign is negative. So I had to check that with my calculator. So the sine and the cosine are both negative, which means we are in quadrant 3. So this overall problem for the subtraction of the two angles ends up in quad 3. And there are my individual fractions. Okay, so now we're going to be looking at the double angle question. And we're looking at 12b. It says find the exact values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta for the given values of theta. And so what we need to do is we need to figure out, using this information and this quadrant, we need to figure out the rest of our triangle, what its signs would be for cosine, sine, and tangent. And just so you know that when you plug into the formula that you have all the correct information. So 90 to 180 is in quad 2. So that's where theta is. And you are going to use this as the triangle you use for your formula because even though these are two thetas, the formula for each one of them uses a singular theta in the formula evaluation. So then this is cosine of negative 12 over 13, so adjacent over height. And we would need to figure out the other side. That's 169 minus 144. Since this is c squared minus b squared equals a squared. That's 25, so square root of that is 5. And it is positive in this quadrant. So that means that my sine of theta over here is going to be 5 over 13. We already know our cosine, and our tangent of theta is opposite over adjacent, and it's a negative and a positive, so negative 5/12. So the formulas are sine of 2 theta is 2 times sine theta cosine theta. So that's going to be 2 times 5 over 13 times negative 12 over 13. That's 10, because this is like 2 over 1. And then times negative 12 would be negative 120 over 1 times 13, which is going to be 169. You would then ask if that reduces any. Let me think. Is 169 divisible by 3? No. I actually don't think this reduces. I don't have a calculator I can check it with, but let's check it on the answer key real quick. Yeah, it's negative 120 over 169 does not reduce. Okay, so then let's look at cosine of 2 theta. Which is going to be cosine squared theta minus sine squared theta. So this one's easy. You just take the cosine angle, and we're going to square it, and you subtract the sine angle squared. So that is 144 over 169 minus 25 over 169. which is going to be that 119 over 169. Because if you take away 20, that would be 124 plus 5 more. Yeah, so 119 over 169. Now here's the great thing. If you have done those, you don't actually need the tan formula for the double angle, because you know that tangent is sine over cosine. And if you put those over each other, you're going to get negative 120 over 119 once it reduces. So we have found all of the double angles for the given value of theta. Okay, so now we're on to 13, which is the half angle formulas. This one is the one that's a little bit tricky because you have to be more sophisticated with how this works. There's two things really going on. When you use your formulas for your half angles, you remember you're using cosine of theta and inside of all those square roots for every single one of them. That theta has a location and the half angle has a different location. The reason this matters is because when you try to derive the half angle formulas, you have to know when you take a square root, you get a plus or minus. So the only reason we need to know the location of the half angle is to determine on each formula, sine, cosine, or tangent of the half angle, whether or not we pick a plus or a minus in front of the square root. Everything else in the problem is based off the location of the original theta. So if we look at C here, this says tangent of theta is negative 15 over 8, and theta is between negative 270 to negative 180. Remember that that is, if you're going around the unit circle this way, so this is negative 90, negative 180, negative 270. So you're in quad 3 for your theta. So theta is in quad 3. So that helps us draw a picture of what that would look like. So then theta is opposite over adjacent, and in this quadrant the opposite would have to be positive. That means that the negative comes from the adjacent, and we would need to do Pythagorean Theorem to figure out if that is a perfect square or if it's going to be something else. And it's 289, which I want to say is a perfect square. I think it's 17. Yeah, so this hypotenuse is 17. Which means the only thing you need for the half angle formula is cosine of theta if you're using the ones with the plus or minus. So cosine here is negative 8 over 17. Okay, so we're supposed to find sine of the half angle, cosine of the half angle, and tangent of the half angle. Now what we found was just what we needed for the inside of each of those formulas. To figure out our half angle's sine, whether or not it's going to be plus or minus, we have to analyze this right here and turn it into a half angle. So if we take each of those and we divide them by a half, that will tell us the location of the half angle. So negative 270 divided by 2 is negative 135. This is now theta over 2. This is negative 90 degrees. So now we're between negative 90, which is here, and negative 135, which is not quite all the way. So that means we're down in quad I think I said quad 3 before, or quad 2. This was supposed to be quad 2. This is why I don't record videos this late at night. So quad 2 is where the original theta was, and quad 3 is where the half angle is because of the way they're going around the circle. So the problem here is that you need to know what sine, cosine, and tangent have as their signs down here. So sine of this half angle, whether or not we have the whole formula worked out or not, sine down here is negative. And cosine of the half angle is going to be negative as well because we're in quad 3. And tangent of a half angle is a negative over a negative here, so it's going to be positive. So the only reason we needed to cut all of these in half is because it's not naturally giving us the correct signs when we cut something in half from the original theta unless we analyze the new quadrant of that location. So what we're going to do now is do all the formulas. And we're going to choose the correct sign based on this, and we're going to use this cosine in our formula. So sine of theta over 2 is going to be negative because of what we found out about that. And then it's square root of 1 minus cosine of theta. So 1 minus negative 8/17 all over 2. That's negative square root of 1 plus 8/17 all over 2. We're going to multiply everything on top and bottom by 17. So this is negative square root of 17 plus 8 over the square root of 2 times 17, which is 34. And that would be the square root of negative square root of 25 over square root of 34. So that's negative 5 over the square root of 34, or negative 5 square root of 34 over 34. So there is sine right there. And I'm going to have to write my other ones somewhere else because that took a lot of room. Maybe we can write them up here. So cosine of alpha over 2 is going to be negative as well because of what we analyzed about the half angle. And then that's square root of 1 plus cosine, which was negative 8/17 for my theta, over 2. We'll get negative square root of 17 minus 8 this time, over 34. And 17 minus 8 is going to be negative square root of 9 over square root of 34. And that's going to be negative 3 square root of 34 over 34 once we rationalize. Now we already have both sine and cosine, so we can just do tangent by making those ratios. Now we know that it's negative over negative, so it's going to be a positive, just like I found out down here. So this is going to be 5 square root of 34 over 34. Oh, and that's negative over negative 3 square root of 34 over 34. Both the radical and the dividing by 34 cancel, so it's 5/3 because the two negatives also cancel. So there are our 3 different half angle ratios. Okay, and that brings us to the last problem on the review, number 14. And we're looking at these trigonometric inverse functions to find the solutions that are in the intervals 0 to 2 pi. Uh-oh, it's doing this again. Hang on just a second. Okay, so I figure on this one we'll try to do 2 of these because this case actually says approximate to 4 decimal places, which means the answers we get at the end are not on the unit circle. So let's look at this first one. It looks like I could try to do some factor by grouping here. I can pull out a 9 and a cosine theta, and I'd be left with a cosine squared theta, or actually I can pull out a cosine squared. Let's pull that out. I want to pull out the most that we can. And that would just be, 4 cosine, because we divided 36 by 9, minus 1. On this case, we can pull out a negative 4, so that would be 4 cosine theta minus 1. So this is 4 cosine theta minus 1, and this is 9 cosine theta squared minus 4, which is going to factor again using perfect squares. That's 3 cosine theta minus 2 and 3 cosine theta plus 2. If you set each of these equal to 0 and solve, you're going to get cosine equals 1/4, cosine theta equals 2/3, and cosine theta equals negative 2/3. So subtracting and dividing, or adding and dividing. And none of those are good ratios. They're not 30/60/90 or 45/45/90. So what we have to do is we have to actually use the inverse button on our calculator, and we're going to approximate the answer to 4 decimal places, and we are in radians. That is super important. Otherwise you won't get the right answer. But the problem is for each one of these, remember, and I keep writing theta there. So we're doing cosine inverse of 1/4. Cosine has 2 locations where it could be a positive ratio. For example, cosine is positive in both 1 and 4. Your inverse button is going to give you this one. It will give you quad 1, because remember, inverse is in 1 and 2 for cosine. You will have to find this one using reference angles. So let's use our calculator. So cosine of 1/4 inverse, so 1/4 and then cosine inverse. And I want to be in radians, so let me do that again. See, very important. So 1 divided by 4 cosine inverse, that's 1.3181. So 1.3181. Okay, so that's the quad 1. We need to also have a similar one here. Now this would be 2 pi minus that angle. So another way of doing that quickly is just to say minus parentheses 2 times pi, and just remember you need to change the sign of your answer. So 4.9651. So 4.9651. So there's those two. Both of these came from just the cosine of theta equals 1/4. So we'll have to do the same thing for 2/3 and negative 2/3. The 2/3 ones is going to have a similar situation where we're going to get a quad 1 and a quad 4 answer. For this one, cosine is negative, and this one is also the one that the calculator gives you. For cosine to be negative, you're over here in quad 2 or 3, and the one the calculator gives you is the quad 2. So you're going to have to find this one, and we're going to have to find this one. Okay, so let's go ahead and do those. And just FYI, if this had said cosine theta equals, 7/2, 7/2 is not between -1 to 1. Cosine sine have to be between -1 to 1. So you would just have a solution that doesn't work. But let's do, it would be a domain error if you typed it in on your calculator. So let's do 2 divided by 3 cosine inverse. That's 0.8411. So this one's 0.8411. And then again, quad 4 would just be 2 pi minus that, so minus 2 times pi. So that's going to be, it's going to be positive if we've done it the right way, so 5.4421. Okay. And then the negative one should be, it should have the same reference angle here, but if we do it on the calculator, it'll give us that in terms of 0 to that radian. So this is 2/3, and it's negative. Cosine inverse, that's 2.3005. Now, unfortunately for you, if you ever get a quad 2 one and you don't already have the quad 1, you do have to figure out what this reference angle is, because you're not going to be able to figure out this one down here without this reference angle. So you need to do minus pi to figure out that reference angle there. That's 0.8411, which we already knew that since we did the quad 1 and it's the same ratio. So we're going to subtract another pi because we want it to be pi more than that. So this is 3.9827. 3.9827. So essentially I figured out what this little extra decimal would be in radians, and then I added another pi to it since it's pi plus that a little bit. So let's double check these solutions with what's on the answer key, because I kind of want to make sure that I had my radian set up right. Yep, we have the 0.8411, the 1.3181, the 2.3005, I think we had that one. Yep, and 3.9827, 4.9651, 5.4421. Yep, we had every single one of those. So just make sure that you realize that every single time you solve one of these, the inverse function only gives you the domain that it is allowed to report that decimal in. There will always be another place where that angle could have another ratio somewhere on the unit circle that's positive or negative, just like that one was. So you do have to know how to find that second angle. All right, so let's look at this very last one. I'm going to do C as well. So this is tangent of, let me move this down a little bit, hang on. Tangent, oops, I didn't want to move it down that far. Let me recopy this one on the next line. So tangent, and that should be C, but whatever. Tangent to the fourth, theta minus 13 tan squared plus 36 equals 0. So we can try to factor this. This would be tan squared and tan squared, since it's tan to the fourth. May not factor. If it doesn't factor, we'd have to use quadratic formula. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9. It's going to be 4 and 9 because it needs to multiply to positive 36 but add to negative 13. So minus 4 and minus 9. And then those both factor again. So that would be tan theta plus 2, tan theta minus 2. That's a difference of two perfect squares. And then tan theta minus 3, tan theta plus 3 equals 0. So we're going to get 8 different solutions if everything works out, because each one of these will provide us with 2 solutions on the unit circle. So we're going to be solving tan theta equals negative 2, tan theta equals positive 2, tan theta equals 3, and tan theta equals negative 3. And it is okay for tangent to be bigger than negative 1 to 1. Tangent can take on any y value. In the graph of tangent, it goes all the way up and down forever. So when we look at this, we're saying, where would tangent have a negative value first before we do the inverse? Because we're just going to type this into our calculator as tan inverse of negative 2 to get our theta. But tan is negative in quad 2 and quad 4. So I can go ahead and draw a similar situation over here. And remember, the reference angle that we're going to get is going to be down here, because remember, it always reports it for us in this direction. It's either 1 or 4 for tan inverse. So if we have negative 2 tan inverse, it gives it to us as a negative, remember, pi over 2 to pi over 2, so it's giving it to us in a negative. I always write that number down as my reference angle. It's 1.1071. That's true for right here. That's that reference angle. We would want that to be 2 pi minus that, though, or actually we would want to add 2 pi back to it to make it positive. So plus 2 times pi. So that actual angle is 5.1760 if we're going from 0 to 2 pi. So 5.1760. And then we would also want to figure out this angle over here. It also has that reference angle of 1.1071. So we would be doing pi minus that. That's 2.0345. Okay. And then we would also have to do tan of positive 2, but that's the same ratio, so it should just have the same reference angle, 1.1071. And then this one would be pi plus that. So pi plus 1.1071. So 4.2487. Because those had the same ratio but just different signs, so they're in different quadrants. So we need to kind of do the same thing here. We can do the tan of the positive 3 first. So we'd be doing tan inverse of 3, and that gives me 1.2490. That's in quad 1, because that's what the inverse button tells me for tan, is if you have a positive ratio, you're going to be in quad 1. 1.2490. And then we know it's going to be the same reference angle for all of these. Since they're the same ratio, just different signs, we just need to figure out what they would be. So this one is pi plus that. So that's 4.3906. And then this one would be pi minus the reference angle from quad 1. So pi minus 1.2490. So that's 1.8926. And this one would be 2 pi minus the reference angle. So 2 times pi minus the 1.2490, which is 5.0342. And that would be all of my different solutions. So let's double check them on the answer key. Make this smaller, just so you can see that we're doing it all with one, especially if you have inverses that both have the same number, but they just have different signs. It's really quick to get those decimals. So let's look at down here. Yep, those are the same exact ones that we received. Yep, we've got all of them. So that is the end of this video. I may not have done every single example that you wanted, but I tried to do one of every type. If you still find you have questions, just reach out and I will see you guys on Monday.